All right, you guys, welcome back. I hope you guys found my last video about the standard enthalpy of formation and standard enthalpy change helpful. In this video, we'll be going over a practice problem and apply those concepts that I taught you about in the last video. So this one is asking us to calculate the standard enthalpy change for the combustion of 1 mole of propane. Now, if you think back to the beginning of the semester when we learned about the different types of reactions, combustion just means we're adding oxygen to this substance, and it's going to react by producing liquid water and gaseous CO2. So I'm going to go ahead and write that out for you. It's going to be C3H8, which is propane, and it says it's in its gaseous form plus. Now it's oxygen, but remember that the standard state of oxygen is O2 and it's gaseous. And we remember that using that mnemonic, have no fear of ice cold beer. And then we're going to produce liquid H2O and gaseous CO2. Now, the first thing you need to do always is to balance this equation. So if you're a little bit unclear about how to balance an equation, we've got a great video about that on our page, but I'll go through this pretty quickly for you. So we have 3 carbon with the reactants. We're going to need 3 carbon, 3 CO2 for the products. We've got 8 hydrogen in the reactants. We need 8 hydrogen, so 4 H2O, and that's going to give us 10 O2 on the product side. So we need 10 oxygen, so we need 5 O2 on the reactants. So now that we have our balanced equation, let's go ahead and write out what our formula is going to look like without the numbers. So the numbers you see up here are the standard enthalpies of formation that we're going to use to calculate the standard enthalpy change. So the change in enthalpy for this reaction is going to equal the products. So it's going to be H2O and carbon dioxide. So it's going to be 4 times the standard enthalpy of formation for H2O plus 3 times the standard enthalpy of formation for CO2. And then we're going to subtract the reactants. So it's going to be subtracted by 1 times the standard enthalpy for propane plus 5 times the standard enthalpy for O2. All right, so let's go ahead and plug in our numbers. So that's going to mean change in H reaction is going to equal 4 times negative 241.82 plus 3 times negative 393.5, and then we're going to subtract 1 multiplied by C3H8, which is negative 103. And then we're going to add 5 times O2. So remember what we were talking about, the standard enthalpy of formation in the last video. O2, which is gaseous, is in its standard state. And we're going to assume that this reaction is occurring at STP because they didn't give us a standard enthalpy of formation for O2. So because it's in its standard state at STP, the enthalpy of formation, the standard enthalpy of formation is going to be 0. That's really important to remember when you're doing these problems, because it'll help you remember that that's going to be equal to 0. So you don't actually have to include it in the equation, but I wrote it out for you just so you guys understand that O2 has a 0 enthalpy, standard enthalpy of formation. So once you go ahead and plug that in the calculator, I'm going to give you a little bit of time to do that. And then I'll write it out for you. All right, so you should have gotten negative 2043.93 kilojoules per mole. Kilojoules per mole is usually what you'll see enthalpy in. Sometimes I've seen it in something like joules per mole or even like joules per gram. So make sure you're paying attention to your units and giving the answer that you want, that the professor wants on a test or quiz in the correct units. Something important you can look at to check your work. So a combustion reaction is a spontaneous reaction that occurs, and it is, I'm not going to say always because there's usually an exception, but almost always it's exothermic. So it's giving off energy. So in this case, it's negative. So it's not absorbing energy, it's giving off energy. And that's usually also an exothermic reaction is usually spontaneous. We know that combustion reactions are spontaneous. So that kind of helps you check your work and make sure that everything aligns conceptually. But that is it for standard enthalpy change for combustion of 1 mole of propane. And if you have any questions about this problem, please feel free to reach out to the Rinella Center and we can help you out. Good luck on your next test or quiz. Thank you guys so much for watching.